reviewing here for your systems of equations test. First thing is by graphing. You must use graphing to solve these first ones. All you're doing is graphing each one. Y equals mx plus b, starting at -4, going up 3 over 1, up 3 over 1, graphing your line. For the second one, starting at +10, down 1 over 2, down 1 over 2, graphing your line. Where the two lines intersect is your answer. That's at the ordered pair 4, 8. For this one, you don't have y by itself in this first one, so what I'm going to do is get y by itself. So 3y equals -2x plus 6 by subtracting 2x over, divide everything by 3. So it's -2/3 x, and then this will become +2. So starting at +2, down to the right 3 each time for your graph, and here is your line. Now this one, x equals -3. That's the only time that you start on the x-axis because there is no y to begin with. So you're going to go straight up and down, and you'll look and see where your intersection point might be. So this is where you need to be precise with your graphing. If I can move the right thing. There we go. So as you graph, it goes up to the right 3. So there's your intersection point right there at the ordered pair -3, 5. So your intersection there, that's your answer, is the intersection. You must use graphing for the first two. Now, for the next pair, now you need to use substitution. With substitution, what you need to do is to get y by itself or x by itself in any one of the equations. Sometimes they'll give it to you with x or y already by itself. So what I'm going to do here is I'm going to choose to add y to both sides of this equation and give me x equals y plus 1. Now x is by itself, I can go and plug in 4x in the other equation. So that means now in place of x, I'm making it y plus 1 plus y equals 3. So all I did is I replaced x with what's in the box. What's in the box? So 2y plus 2 equals 3. That means 2y x will equal -4. Again, go and plug back in. Well, you already have y by itself, so y equals 2 times x minus 1. So y equals -9. Your ordered pair, -4, -9. In 5 and 6, this is where you're using elimination. So with elimination, you need to have two by themselves variables, or not by themselves, but have the same coefficient. Let's look at 6 first. In number 6, the y's are already the same number but opposite signs. So if I add them up, they'll cancel out immediately, leaves me with -2x equals -6. Divide both sides by -2, gives you x equals 3. Then again, you can go and plug back in. Doesn't matter which equation you plug into. I'll say the top one just because, and I'll plug in that x value. And now I will solve. So I get 21 minus 5y equals -24. -5y is going to equal -45. So y is going to equal 9. So your answer is 3, 9 for that one. In this first one, you don't have anything that's the same. Well, 5 to 10 I can get pretty easily by multiplying by 2. I'll multiply by -2 to make them opposite signs. So I'll give me -10x minus 6y equals -20. Keep the second one the exact same. And now I can solve by adding them together. Those will cancel. Gives me 10y equals -20. So y will equal -2. And from there, plug -2 back into one of the equations. Doesn't matter which one. I'm picking the second one just because. 10x plus 16 times -2 equals 0. 10x will equal -32. So x equals, will be positive 32 because it was -2 there. So it'll be positive 32 over 10, which reduces to be 16 over 5. So the ordered pair is 16/5, -2. 7, 8, 9 you can do in any method you want. There's showing you both an elimination step at the top or a substitution step on the bottom and the steps that you would choose. Mainly look at number 8. There's no solution for those because no matter what you do, you get to a point where you have an answer here and you get a false statement. You get a number equaling another number. That is not going to work. That's a no solution as a result. Okay, next section, system of 3 equations. These are the big ones that you're going to have to work with. So I'm going to do first, I need to pick a variable to eliminate. I'm going to choose to eliminate x just because I can. I'm going to suggest labeling them in this way. I'm going to get rid of x first in equations 1 and 3. So I rewrite 1. And to eliminate x, I would need to multiply the bottom guy by 4. So I'm going to multiply that entire bottom equation by 4. So give me plus 8y minus 20z equals, and this will become 64. Now I can add them together. The x's will cancel out, and it will leave me with, excuse me, a 5y minus 19z equals 54. Now, pick two different equations. I'm going to say equations 2 and 3 this time. For 2 and 3, I can multiply the bottom equation by 2 this time to be able to get them to eliminate. So with 2 and 3, rewrite 2 because I'm not changing it. And the third one, multiply everything by 2. So it'll be negative 2x, positive 4y, negative 10z, and 34. Add these guys together, they cancel out. My answer becomes 5y minus 7z equals 34. So now I got two new equations. I'm going to call them 4 and 5, and that's what I'm going to use for my next step. I need to somehow eliminate something in 4 and 5. Well, they have the same y value, just opposite signs. So I'm just going to make one of them a negative, so make the second guy multiply by negatives. Keep the top one the exact same. And now they will eliminate. Those will cancel out, and it'll leave you with negative 12z is equal to, well, let's look back. Hang on, I made a mistake up here. This shouldn't have been 64, it was 34 times 2, 68. So this would have been 58. My apologies on that. So this was 58, which means this becomes 24. So z will equal negative 2. That just shows you how one little mistake can end up messing lots of things in your process. But now you have z equals 2, so that's a good start. Now you need to start working backwards. So take it into one of these little guys, either equation 5 or 4, and solve that equation first. So I'm going to do 5y minus 7 times z equals 34. Solve it. So 5y will equal, if I add 14 to both sides, or not, it is plus 14 here, so subtract 14 from both sides to get 20. So y will equal positive 4. And now I can take that number and plug it back to one of the originals. So I need to take this z as well to plug it back into one of the originals. And I'll do that here in white. Doesn't matter which one I do. I'm going to pick the middle equation just because. 2x plus, I know what y is 4. Plus 3 times z, z is negative 2, equals 0. So 2x plus 4 minus 6 equals 0. 2x minus 2 equals 0. So that means 2x equals 2 or x equals 1. Now you have all three pieces. 1, 4, and negative 2 as your ordered triple. Okay, next problem. With this one, you got a lot of things missing, which is kind of good and kind of bad. What I'm going to look at first is if I take the second and third equation, the z's will cancel out just by adding them. So y plus z equals 7, and x minus z equals 2. They'll cancel out the z's, leave you with x plus y equals 9. Well, I already have an equation that doesn't have a z, just like this one does. So I'm going to call this equation 4, combine it with equation 1, which is x plus y equals 9. Well, when I eliminate those, guess what? Everything cancels out. I'm left with 0 equals 0. This is a true statement. That means this is an infinite solutions problem. Just like we had no solution if it was like 0 equaled 5. When 0 equals 0, that's an infinite solutions. Alright, number 12. This one's a little bit more cumbersome. We're going to start by taking equation 1 and equation 2 because they both have 2x. I'm going to try to eliminate x again. I will make the second equation completely negative so that they're opposite signs. Keep the top one the exact same. Add them together. Those cancel out. I get negative 5y minus 5z equals negative 2. For that equation, now pick another pair. This time I'm going to pick the first equation with the third equation. To get from 1 to 3, I got to multiply the top guy by 3. So I'm going to multiply this guy by 3, make it negative 3 actually, so the signs are opposite. So negative 6x minus 3y minus 6z equals negative 3. Keep third equation the exact same. 6x, yeah, that should be an x there, plus 8y plus 18z equals 5. Those cancel. 5y plus 12z equals 2. And now you will look to solve, because now you have two new equations here, 4 and 5, both without an x. So we can combine them together. Well, guess what? They're already the exact same coefficient with opposite signs, so I can just add them together immediately, 4 and 5. So when I add 4 plus 5, the y's will cancel out, and it'll give me 7z is equal to 0. Well, when I add those together, guess what? Well, they're going to cancel out, or when I divide by 7, I get z equals 0. Look how easy that is. Now start plugging back in. When I plug back into this equation here, z equaling 0, well, that means 5y is equal to 2. Divide by 5, y equals 2/5. And now when I take these and plug them back into one of the originals, take this, plug it back into one of the originals, you have 2x plus y is 2/5 plus 3 times 0 equals 1. Well, that just goes away. Subtract 2/5 on both sides, you'll get 3/5 is equal to 2x. Divide both sides by 2, x will equal 3/10. All right, last portion, the graphing parts. On the first one where we have 4x plus 5y equals -10, get y by itself. Subtract 4x on both sides, so -4x minus 10. Divide everything by 5, so -4/5x minus 2. So start at -2 on the y-axis, down 4, right 5, connect your dots, there's your line. For the second one, y equals 3/5 x minus 2. You already have it in slope-intercept form. Start at -2, go down 3 to the right 5. I'll do it again, down 3 to the right 5. There is your graph. Well, why did I go down? I shouldn't have gone down. Pay attention, Mr. Dotson. It was at -2. It was a positive 3/5, so it should have been up 3 to the right 5. Up 3 to the right 5. So there's your graph with a positive slope. That's why you should check to make sure your graphs are going and sloped in the right direction. Next two, y equals 6x and y equals 6. Y equals 6x is like 6x plus 0, meaning you're starting at the origin, up 6 to the right 1, or down 6 and to the left 1 to connect your dots. Connecting them hopefully a lot better than that one was right there. For y equals 6, it's like 0x plus 6, meaning you're beginning at 6 and you have a horizontal line. There should be no slope when it's just y equals 6. If it was x equaled 6, then you would have started on the x-axis making a vertical line. Last two. For 17, it was -2x plus 2y equals 8. Get y by itself. Add 2x to both sides. 2y equals 2x plus 8. Divide everything by 2. Y equals x plus 4. So starting at 4, the slope is 1, so it's up 1 over 1, up 1 over 1. So there is your line right there. And the last one, y equals -5/4 x plus 1. Start at positive 1, go down 5, right 4, connect the dots, and there you have it.